third lecture of Docker and containers. By the way, just a quick introduction about what we have done in the past. So in lecture 2, we have discussed about the Docker, the MOB project, and how Mirant is taking the Docker enterprise and other container runtime engine. Okay. In this particular lecture, we will be understanding about these things. Okay. So definitely to understand new technology, we have to understand what exactly happened in the past so that we can improvise things accordingly and find out a better solution. Okay, I'm going to use this slide to make you understand in a better way. So in past days, what we have to do, okay, we have to take one physical server and where we have to install operating system. Then on top of that, we have to install and deploy application. Okay, there is no problem with that. But if you think as a production engineer, what are the major problems you're going to face? Okay, so when you use bare metal means a hardware where you are going to install all these things. So this historical application deployment has these many problems. Definitely you can understand that deployment of a new hardware is going to take time, money, and many more things. So as you can see here, it's going to take slow time. The cost will be involved much because purchasing a new hardware every time is a big deal, right? And definitely if your application is not using much resources, so it's a wasted of application as well. Okay, I mean resources as well. And scaling is also a big problem because scaling up hardware is you're gonna shut down the OS, increase the RAM or CPU or storage, then start it again. So difficulty in scaling is really obvious. And now migration. If you want to migrate your application from one hardware to another, that is also going to be a problem. So vendor locking means, yeah, let's say you purchase one hardware from IBM and now you want to migrate to any other thing. So whatever challenges you will be having with the IBM hardware, you have to troubleshoot all those. Okay, so you can clearly understand bare metal is not the right solution for today industry. Okay, so what solution we found in the past days? When we talk about solutions, we found one of the amazing technology, that is hypervisor, or the technology called virtualization, and that is based on hypervisor. You might have heard about VMware, VirtualBox, KVM, or many more like that, where the idea is to divide your one physical server into number of virtual machines. So definitely if you have one physical machine like this, okay, so and you want to install and deploy multiple application like Java, PHP, Python, database, and many more, so you don't want to install them in a single machine. The reason being because they might be having some conflict issues. So virtual machine was amazing, right? And we have seen virtual machines in the past. Definitely, we will be talking about the downtime and uptime, both about the virtual machines or this virtualization technology. So just have a look here. What are the major benefits of using virtual machines? Okay, better resource pooling. Definitely, if you have a physical machine and from there you are only grabbing that amount of resources to a particular machine, that is exactly required by your application. So one physical machine can be divided into multiple virtual machines because that's how the virtualization concept came. It is also easier to scale because you might have heard about cloud computing and other model where you can scale your virtual machine from 1 to 2 and 2 to n number. Due to virtual machine, the concept of cloud computing also came in picture, where you can install, deploy applications, and provision virtual machines in a very fast way, and you don't have to pay much as compared to bare metal. There are some big vendors providers of virtual machine cloud like Microsoft Azure, Amazon, and VMware. Okay, but definitely when you use some technology there will be some downside. So let's understand the limitation in virtual machine. So this thing we have also discussed a little bit in lecture 1. You can go and check. So if you talk about limitation, virtual machine is what? It's entire running or stopped operating system. When you need an OS, definitely you need a CPU, a RAM, and storage, and most importantly, entire operating system. So if you create multiple virtual machines, definitely the more resource you need. That's what it is written. Okay, and the most OS take much resources as compared to the application need. For example, let's say if I go back to my slide here and want to tell you something, let's say I want to run my Python application. So this is my Python application. I have written a web app in Python, Flask, or Django. Okay, then I want to test this application, is it running or not. According to my experience and in reality also, it's not required more than 100 MB RAM and more than 0 point something percentage core CPU, and not exactly more than 100 MB storage. And to test this application, you don't need more than 2 to 5 second time in reality. Okay, just to test it. So when you need this much small resources in virtual machine, you are paying much. You're giving much because when you need an operating system, you have to give CPU, storage, RAM, and many more things like that. And an operating system really need at least 1 GB RAM, a core CPU, some storage, and the time. But why I'm creating that OS to deploy this application? So that's why I need to focus on only that particular part of OS that is required by my application. That's why these are some downsides or drawbacks of using virtual machines. So definitely, what is solution to that? Solution is containers. Okay, container are not exactly similar to virtual machine, but in terms of virtual environment, they are similar. Okay, so we have also discussed something about container in lecture 1, but that was not enough. So here you can understand something. Okay, so if you talk about containers, so container are technology that is going to use your host kernel. Remember that point, host kernel, meaning if I have my operating system in the host system, so this is my OS, and let's say I have kernel here called Linux. Okay, so I am having a kernel called Linux. Okay, it doesn't matter Linux is using Fedora or any other operating system like Red Hat and all. So the moment you install any container runtime engine like we discussed in the past, let's say Docker, and I have one, let's say a Java application. So what is going to happen? Docker will use this kernel, Linux kernel, and create one tiny OS where your Java application is there. In fact, only Java application is there. And this running instance that have only single process as of now, single process, and that running instance is nothing, it's container. So you can see in the diagram, container are the one who can have the same OS kernel because definitely the kernel is common for all container. And it works with all major Linux and Windows distro. So here you can see this container is having Tomcat, Java, and Debian. What is Debian? It's a Linux OS, okay? Because to install and deploy any application, you need file system, and file system can be provided by OS, okay? This small detail you can also Google it. What is file system and what is the need? Second container is running MySQL server. The point is this is not virtual machine. So meaning this container is not having anything apart from Java and Tomcat. Otherwise, the size of container and resources will be increasing. Likewise, this container is also having .NET and SQL Server, and this container is having only few libraries with OS. Okay, so when it comes to Docker is going to create a running instance with a particular platform. Likewise, if you need another application to be hosted, let's say Python application, then this container also using the same kernel, and here only Python support or Python libraries and Python process will be there. There will be no my computer, no system, nothing like that. So I have container 1, I have container 2. Likewise, I can keep creating containers in near future. So why Docker, right? Because Docker is the most easiest way to manage and create container. So definitely we'll be understanding in near future what how to install Docker and how to create container. But I'm sure you are having few ideas about container. So if I revise the same thing here, containers are the most tiny runtime, entity, or something environment that can hold your application, and that container will be having only those libraries and dependency that is required by your application. It is not having anything else. Okay, so simply uh, other container runtime engine we have already talked about in the past lecture. So see you in next lecture with the practicals there. Okay, thank you and have fun.